Picture this, a stone tied to a string, swirling around in the air, a carousel spinning in endless rounds, or the Earth itself rotating on its axis. These are all examples of a fascinating physical phenomenon known as circular motion. Circular motion is the movement of an object along the circumference of a circle or rotation along a circular path. It can be uniform, with constant angular rate of rotation and speed, or non-uniform, where the rate of rotation or speed changes. Consider a merry-go-round. As it spins at a constant speed, each horse moves along a set path, changing direction but remaining at a fixed distance from the center. This is known as uniform circular motion. However, if the merry-go-round starts to speed up or slow down, the horses then experience non-uniform circular motion. Here, both the speed and direction of the horses change, creating a different sensation for the riders. Now imagine a race car zipping around a circular track. The speed of its turn isn't measured in the typical miles per hour, but rather in angular velocity. This measures how many radians or slices of the circular path it covers per second. The faster the car, the higher its angular velocity. But what about the spin of an object? That's where angular momentum comes in. It's the product of an object's moment of inertia, which is determined by how its mass is distributed and its angular velocity. So, a spinning figure skater has a greater angular momentum than one who is stationary. And what happens when the speed of the spin changes? That's referred to as angular acceleration. It's like the gas pedal for spinning objects, indicating how quickly their rotation is changing. Lastly, there's the concept of centripetal acceleration. This is the force that keeps the riders on the merry-go-round from flying off, even as they constantly change direction. This force always points towards the center of the circle, keeping everything moving along its circular path. To see these principles in action, consider the rotation of the Earth, which is an example of uniform circular motion, or a record player, where the turntable provides uniform circular motion for the needle. A washing machine displays non-uniform circular motion as it speeds up and slows down during its cycle. Figure skaters manipulate their angular momentum to spin faster by pulling in their arms and increasing their moment of inertia. So, circular motion in all its forms is all around us, from the spinning of the Earth to the rotation of a record player. It's in the dizzying spins of a figure skater and the thrilling turns of a race car. It's a fundamental concept in physics that helps explain the movement of objects in our everyday lives.